In this video, we will be learning about simple reaction patterns that will help support our learning objectives for describing precipitation reactions and acid-base reactions. So when we talk about chemical reactions, there's some observable phenomenon that we can see. So for instance, sometimes when we mix things together, there's precipitation, meaning a solid forms. Other types of reactions are redox reactions, which are usually more violent reactions involving a large release of heat, color change, light, etc. Acid-base neutralization reactions also have some observable change in properties, such as becoming more neutral, and they are exothermic generally. When we write out the chemical equations for these types of reactions, we can see that there's some simple patterns for how the reactants rearrange themselves. So like how the atoms and parts of these compounds rearrange. And so in this video, we will be talking about the simple reaction patterns such as double displacement, single replacement, combination, and decomposition. Once we learn these patterns, we will learn how to apply them in order to predict the products of the reactions for these things. So the simple reaction patterns that we're going to be learning about include combination reactions. In combination reactions, you start off with two separate things, and then they combine together to make one thing. And so in this compound, you have A and B, and then they will react together to form A and B bonded together. Sometimes combination reactions are called synthesis reactions because you are making something new. Decomposition is the opposite of combination. So you can see here that instead of A plus B becoming AB, we start with AB and then it breaks apart. It decomposes into A and B separate. It doesn't matter which letters you use. So in this picture, it's using letters C and D, but the same principle applies. It starts off as one compound and becomes two separate compounds. Single displacement, also sometimes called single replacement, depending on which source you're looking for. Then you have A plus BC, that's one compound with two different components. And then A will either kick out B or A will kick out C, depending on whether A will want to behave like a cation or whether A will want to behave as an anion. So in this case, A is kicking out B to become a cation bonded to C, and B is kicked out. So A kicks out B, now B is by itself, and now A is bonded to C. In a double displacement reaction, you have your cations and anions switch partners. And so we know our cations are always listed first, and so our cations are A and E. And so once we finish this chemical reaction, C here will now be bonded to F, and E will be bonded to D, so that we still have cation and anions, but now they're swapped with their partners. These new products are what we can call ion exchange products, meaning we have exchanged which ions are bonded to each other. And so the cations and anions switch pairs. And so when we talk about our observable phenomenon, our precipitation reactions and our acid-base neutralization reactions all follow this pattern. Here's some actual chemical equations, and so we'll see how these patterns fit. So I'll go through these, and then there's a practice problem afterwards. So I'm supposed to identify these as either single displacement, double displacement, combination, or decomposition. In this first one, we have A and B forming A and B bonded together, and so that's a combination reaction. Now we have potassium, I'll label that A, and water, and so I'm going to call that B. And then I can see over here that it's actually hydrogen by itself, and this is an OH. Sometimes it's helpful to, instead of writing water, write it as HOH. And so you have two HOHs. And so in this case, A is kicking out one of the hydrogens, and so one of the hydrogens is a B, and then the OH is a C. And so now B is by itself, and you have A bonded to C. And so this is a single displacement. If you do this reaction in real life, it actually catches fire, which is pretty cool. All right, now for this third one, we have A and B, or maybe not. Maybe it's just, we call that A. Maybe this whole thing is A, and this whole thing is B. And now they've merged together to make C. And so this is going to be a combination reaction. You can see that sometimes these letters represent one element, and sometimes these letters represent more than one element. So for this next one, I can see I start off with one thing, and so I'll call that A and B, and then it's split apart into A and B. If you do some little addition with your reaction, you can see that we do end up with 3 oxygens, 1 carbon, and 2 hydrogens. So it is a decomposition reaction. It's just that that's a little weird to see it written as A and B when there's 3 different elements. But hopefully that helped clarify the labeling. Now for this bottom one, I'll call that A and B, C and D. And then that's A bonded to D and C bonded to B. And so that's double displacement. Oh, come on. Here's a practice problem for you. I want you to identify each of these reactions as either being a single displacement, double displacement, combination, or decomposition. Pause the video and work this out on your own, and then unpause the video when you're ready to check your work. All right, so this first one here is A and B, and now it's A and B bonded together. So that is a combination reaction. I see aluminum by itself, and then that's 2 substances, and now aluminum's bonded to that. So that's A, B, C, and now it's A bonded to C, and then B by itself. And so that's single displacement. Now I can see that I start off with 2 things, and now they're bonded together. So that's a combination reaction. And here I have A, B, and then I guess part of A included some oxygens. That's a decomposition. And now I have A, B, C, D. So this is going to be a double displacement, because that's the only pattern we learned about that starts with 4 different letters. And so we have, this is C bonded to B, and that was A bonded to D. That concludes our tutorial on simple reaction patterns.